Now let's see this problem, okay? We need to use the longest job for scheduling algorithm, and then we need to find out the turnaround time, waiting time, schedule length, and then throughput, okay? Fine. Now let's first draw the Gantt chart, okay? Our Gantt chart as usual will always start with time unit 0, fine. Now at time unit 0, the only process which has arrived, see, be aware that it is a non-preemptive scheduling algorithm, okay? Longest job for scheduling algorithm is a non-preemptive scheduling algorithm, fine. Now at time unit 0, the only process which has arrived is P1, right? Apart from that, no other process has arrived, so we will schedule it, fine. And it will go on till 12 time units, okay? Because we cannot preempt it in this gap, even if some other process with higher burst time has arrived, right? We cannot actually preempt this process P1. Fine. Now at time unit 12, all the processes has arrived to the RAM, right? All the processes arrived to the RAM. Now out of those, which process has the longest burst time? The longest burst time is nothing but process P3, right? Process P3 will continue for 18 time units. So 12 plus 18 is nothing but 30. Fine. So P1 is done. When P3 is done, then we need to schedule process P5 because P5 has a larger burst time than P4 and then P2. Fine. So if P5 is scheduled, it will continue till 46 time units. Fine. Right? Fine. Now after P5, P2 will be scheduled because 15 is greater than 2. So if P2 is scheduled, it will go on till 61. Okay. Now once P2 is done, the only process which we have is process P4, and so P4 will be scheduled. So P4 will go on till 63 time units. Okay, fine. Now let's compute the completion time, turnaround time and all this. Okay, let's first compute the completion time. Okay, this is P1, P2, P3, P4 and then P5. Okay. Fine. The completion time of process P1 is 12, right? The completion time of process P2 is 61. The completion time of process P3 is 30, fine. The completion time of process P4 is 63, fine. The completion time of process P5 is 46. Okay. Now let's compute the turnaround time. Okay, turnaround time is the amount of time spent by a process in the RAM. Okay, which is nothing but completion time minus arrival time. Okay, we have seen a lot of problems. So 12 minus 0 is 12, fine. 61 minus 1 is 60, fine. 30 minus 2 is 28, fine. 63 minus 3 is 60, fine. 46 minus 4 is 42. Okay, fine. Now let's compute the waiting time. Okay, let's compute the waiting time. See, again we assume that IO time of all the processes is 0. Okay, IO time of all the processes is 0. Fine. In that case, waiting time equal to turnaround time minus burst time. Okay, turnaround time minus burst time. So 12 minus 12 is 0, which means process P1 has not waited for any time, which means it came at time unit 0 and it got the CPU time unit 0. Fine. Now turnaround time minus burst time. So 60 minus 15 is 45. See, this is actually 60. Okay, fine. 60 minus 15 is 45. Okay. Now then 28 minus 18 is nothing but 10. Okay. So 60 minus 2 is nothing but 58. Okay. Then 42 minus 16 is nothing but 32. Then 26. Okay. Fine. So we have computed the completion time, turnaround time and then waiting time. Then let's compute the response time. Okay. And as you all know, response time is nothing but the initial time waited by a process before getting the CPU for the first time. Okay. That is what we mean by response time. And in case of non-preemptive scheduling algorithm, as we all know, response time is nothing but waiting time. So it is as we can copy it as it is. Okay, 0, 45, 10, 58 and then 26. Okay, fine. Completion time, turnaround time, waiting time and then response time we have computed. Now let's compute the schedule length. Okay, schedule length is nothing but very simple. 63 minus 0 is 60. Okay, 63. Okay, 63 minus 0 is 63. So schedule length equal to 63. Fine. Now let's compute the throughput. Throughput is nothing but number of processes completed divided by schedule length. Number of processes completed is nothing but 5 and schedule length is 63. So throughput is 5 by 63. Okay, fine.